Let's do with
our-
oxygen. So what's our next step? We're gonna have 4. First we have glycolysis, then
we're going to glycosylate 3-phosphate.
second step though. We're gonna go our big steps, not our sub ones.
Okay.
So that would be a subtype or acetyl-CoA formation.
Acetyl-CoA or is it ATP?
Or so you guys saw in here, you'll have like
okay, those
ATP and
steps.
but the 4 big steps are going to be glycolysis, acetyl-CoA. Oops.
The Kreb cycle and the transition. Is that right? Oh, man.
So I'm trying to follow this chart.
Yeah.
So where are you at right now?
Is he in glycolysis now, or is he in a whole different step?
This chart, this is all glycolysis.
That is all
that's
glycolysis.
one step.
So you're going to go through the glycolysis, and then let's see if in this book.
It's probably not, but I have my list. Not to worry. Not to worry.
No fear.
One sec. So glucose. Our next step would be.
So glycolysis, go to the next slide.
Carbohydrate.
You're still in glycolysis.
Lactic fermentation.
Okay, so lactic acid fermentation will be over here. If you don't have oxygen, your next step is going to be lactic acid.
What? So we can't go to pyruvate. So let's try this. Oh, so we don't go to pyruvate acid. We go to acetyl-CoA.
Well, during glycolysis, you're going to make 2 pyruvates.
Glycolysis.
And then your 2 pyruvates are going to be changed into lactic acid.
What about?
But
I'm talking about aerobic.
for aerobic, you're going to still make, because glycolysis is making 2 pyruvates.
2.
But then you're going to make your pyruvates into what we call acetyl-CoA. So that's your second big step, or your second process. Then you're going to go into what we call the Kreb cycle, or the
transitional.
that was another name for this one.
That's another name.
Or citric acid cycle. Either one.
Citric acid, TCA cycle.
So that's the 4th one. And what does TCA stand for?
I was just trying to figure that out.
Is it Kreb cycle?
Or sorry, electron transport chain. So E
That's the fucking
is the 4th step, electron transport chain. And so what you're doing right here is cellular respiration. We're going to take the glucose that we put into our body. Let's say our Lucky Charms we eat for breakfast. Then we're breathing oxygen, right? Here we're going to make pyruvates and acetyl-CoA, and that's going to go through and give us a bunch of things to then go to the electron transport chain in exchange for 38 ATP. So there's like the really big picture, and then we'll go in and we'll break down each.
38 is the amount we want to receive, right?
Total.
Okay.
Through all that. Whereas here we're gonna just go to lactic acid. So which one do you think is more productive? Aerobic.
Because, you know, oxygen's kind of important.
You know, we kind of like to breathe.
So why is it more productive?
Because we're going to get 38 ATP. Here we get 2 lactic acids.
Okay.
So 38 ATP, that's the whole point of kind of eating, is so we can fuel our body, give it energy,
Right.
so our heart can be, because we use ATP and muscle contraction, you know, all those different things.
Okay.
But once it becomes lactic acid, can it go... Okay, so I know that anaerobic? Okay,
Anaerobic.
If you don't have oxygen, then it goes, like you said, through lactic acid. But isn't it when oxygen comes back into the system, it can go ahead with...
Yeah, then you could kind of whoop.
You just kind of go back into it.
But if we don't have any oxygen, like kind of ever, yeah, we die. And our blood's going to become more acidic.
So this is what he meant by when he was doing this thing then, with glycolysis. Is that what he's talking about there?
In this picture, kind of. So this is saying if we don't have
then you go
oxygen,
to the
lactic acid.
And if you get it back, you can go back to the pyruvate and then go down. But if you don't, then obviously, you know.
Right. And so if you're just following it straight down, that would be aerobic because we have oxygen. So Manny, what she's saying is, let's say we don't have oxygen
Mm-hmm.
in our body. We're going to go from our 2 pyruvates that we produce during glycolysis, and we're going to make lactic acid from them.
Right.
But, so, and then this process is done. But if we do then have oxygen, we
Then the
can
lactic
go
acid
back
would-
up here.
Let me see what it depends. So the lactic acid would be taken back by, we'll go back to
Our
2
pyruvates.
pyruvates, and those would transform to make ATP.
And those will transform to make,
Acetylcholine to the Krebs and DC to make eventually ATP.
bingo.
That's why when you're running, you're sprinting.
Yeah, because
You-
this would be a time where we don't have a ton of
Yeah.
oxygen.
You're losing oxygen, but the carbon monoxide is building up.
Right.
So
So we're making lactic acid
right,
when we work out.
pyruvates lactic acid, which causes that burn. Once you stop running, you hyperventilate.
And we have some oxygen.
Get some oxygen. We'll take lactic acid back to make 2 pyruvates. Well, 2 pyruvates will become acetylcholine. The Kreb cycle will make ATP.
Perfect, yeah. Beautiful.
Very nice.
So does that make sense, the overall? Okay, we good here? Because then we'll go into just glycolysis, which is going to have 4 subtypes. 4 sub-steps.
Let's see.